Hello everyone. Today we discuss about stack and subroutine concept, stack and also subroutine concept in a 8085. Okay. So this is a very important stack and subroutine concept. Okay. So in the first session we discuss about the operation of stack, and the second session we discuss about the subroutine concept. Okay. So first of all, what is a stack? Stack is a location in a read-write memory where you use the stack for temporary storage of data, and as mentioned by the programmer or the user, we can retrieve the data from the stack and also to store in the stack. Okay, so this is basically, we consider this is our read-write memory. Okay, this is from 00 hex to FFX location. Okay, so there are various instructions are available which are related to the stack. So first instruction is LXI SP 16-bit address. This is very important because this is for initialization of stack. So this is for initialize of stack, otherwise we cannot understand properly where the stack is starting or where is the stack is located. Okay, so this LXI means load immediate to the register pair. This is an 16-bit register stack pointer in 8085, and say here we use the address FFFF. So that means the stack pointer is located to FFFF hex memory location. Okay, so that's why this stack pointer is located this. And if stack pointer is located FFF hex location, then the number stored in the stack is starting from SP-1. That means FFFF-1. That is, the number is stored from this FFFF-A, FFFD, and this direction is go to the upward. Okay, one thing should be remembered, that the principle of the stack is the last in first out principle. The principle of a stack is last in first out concept. So this is very important. So last in first out means the data which is entered in the last in the data insert operation, and when we retrieve this data, then last data in the stack is coming out the first. Okay, so this is the LIFO principle. There are lots of principles available like a FIFO, but stack principle is the LIFO principle. So the last number which is stored in the stack, which will come out first when we retrieve the data from the stack. Okay, so first of all, this is the initialization of stack pointer. This is very important. So now there are several instructions are available. This is a push instruction. The format of push instruction is push 16-bit register. There are different types of register available like a BC pair, like a DE pair, like a HL pair, and another register is known as PSW. What is the meaning of PSW? PSW means program status word. That means both 8-bit accumulator and 8-bit flag register are together is also known as program status word. Okay, so if we write here push B, that means in the stack memory location first store B and then C, and if we apply then push H, then here is store H first and then N first. So between this register pair, the MSB bit is stored first and then LSB bit is stored. Okay, byte is stored. So this is the principle of push instruction. So using push instruction, what is the advantage of this instruction? The advantage is that using this push instruction we can insert the data into the stack. Okay, so now next, how to retrieve the data from the stack. So for retrieve the data from the stack, we using pop instruction. There are lots of registers are available, pop. So this is only works for the register pair, not only the single pair register. Okay, so this is also the PSW, and both accumulator and flag register accumulated to each other and known as PSW. So if we mention this instruction, so first of all, let us write any small program. Say this is for an example, just this is stack pointer. Okay, which is initialize FFFF, and say we push H first. So what is the position of stack? So this is a stack pointer. Okay, so starting from FFFE the number is stored. So first value is H and then L, because we execute push H instruction. So push H means first MSB byte is stored and then L value is stored. So now when we execute this pop B instruction, that means in the BC register pair the value of L coming first, because you already know that the principle of stack is LIFO principle, last in first out. So what is the last in? The last in data is L. So L comes out first and then the H comes out and stored in the B register. Okay, so this is very easy. So this is the operation of stack in 8085. So stack is very used for call instruction. In the next video we will discuss about that. Call is basically used for the subroutine purposes, or any kind of interrupt which is held in 8085 also use the stack operation. There are lots of operations where the stack memory are used, and one thing should be remembered, that the stack memory is always initialized in the last location of the memory. Why? This is very important, because if we initialize stack anywhere, then it will be superimposed with the main program. That means, what is the meaning? Say suppose our main program starting from 8008 location, okay, and we starting address of our stack pointer is 8010. So now this main memory is from top to down and the stack is from down to top, because if we write the code here, say MVIA, okay, so lots of memory are required, 8001, 8002, and the subroutine and the stack pointer initializes 8010. So what is the problem? The problem is that this stack memory data and our data which is used in our main programming main code in a main program, that are what can I saying? What I am saying, that the data is like a, if we starting from this 8010, so now our target is 8010 is a stack pointer, okay, and the main memory, the data is there are lots of code and data are available. So that's why the data is chances to destroy or to overwrite this data between the stack and our code, because our code is going top to down approach, but the stack is down to top approach. So that's why in any time these two data are overwrite to each other. So that's why this is a disadvantage for the stack operations, okay. So that's why we use this stack memory location in a very far away from the main memory, okay. So there are lots of advantage using the stack memory. In the later video will be show discussly what are the advantage of the stack, okay. So now our next target is subroutine program. So what is subroutine? Subroutine is basically a concept by which a part of a main memory, that means some let us consider some part of a code in a main memory which is used repeatedly in a main program. That's why you use subroutine concept. So what I am saying, let us consider these are main program, okay. Now consider a block of code. Here you written a block of code just for the consideration, and here the end of our main program, okay, and here block of code are used repeatedly in the main program. So for the to increase the better efficiency for a coding purpose, the programmer is not written this code repeatedly in the main program. That's why you use the concept of subroutine, and here we initialize one subroutine program, and these block of code are written here. These are block of code. These are block of code written here, and from the main memory, using call instruction, which is target to the subroutine address, subroutine starting for any 16-bit address, which is also available in the read-write memory. This is calling by the 16-bit address, okay, and after execute this subroutine program, it's return, and after return it will again come out this main program and execute until the end operation is performed, okay. So that's why subroutine is very important. But what is the advantage? The advantage is that these block of code are not repeatedly written in the main program. When it is necessary, we just using this call instruction, we can call this subroutine, and after execute this subroutine program, we using this return instruction, we can return this main program. So this is the primary advantage. But how subroutine works? There are basically two instructions are available. Number one is call 16-bit address, and number two is return. This is implicit type addressing mode, because return has no operand, it's just only the return. So how will get microprocessor recognize that the return goes from subroutine to memory? Let us discuss about that. So first of all, consider from 8000 location we starting our main code, and from 8004 we here execute call 9000. So our subroutine, first subroutine address is, this is our subroutine 1. Subroutine start from 9001 and 9000, and consider in a 900A we'll execute return instruction, okay. So call is a basically 3-byte instruction, so that's why 8005, 8006 are used in a call instruction. So 8007, and just consider in 800A here instruction halt are used, that is end of the main program, okay. So now this is the starting location of our main program, this is the starting location of our main program, this is a main program, and after some instruction execute, the call instruction is performed. Call is a 3-byte, so that's why 8004, 5 and 6 are required for to initialize this call instruction. And where is the return? The return address is 8007, because when this call instruction is execute, then program counter, the last program counter value is 8006, and after call instruction is executed, the program counter is changes 9000, because it's get the new location to execute this subroutine address, okay. This is 9001, this is 9002, and so on. So how microprocessor will be known that this subroutine is written here? Here the concept are coming, because you already know that in 8085 there are two temporary register available, one is W and Z. So when call instruction is executed, in the later video we will discuss about elaborately discuss about the call and return instruction using machine cycle. Here we just talk about the operations, okay. So when call instruction is performed, then microprocessor temporarily this 8007 data is stored to the stack by this WZ instruction, okay. Using this WZ instruction, using this WZ register, the microprocessor will be saved this 8007 this address in the stack memory location, okay. In the stack the 8007 will be stored, and when it goes to the subroutine, that means the program counter content is changed to 9000. So before here last program counter value is 8006, okay. So when it jumps to the subroutine, the program counter value is new value updated 9000 hex, and after 9001, 2 and A, when return instruction executed, then microprocessor using this return instruction, it understand that the control of this program is jump from this subroutine to the main program, and what are the location, and this location is coming out from the stack again W and Z register, and place the WZ register value in the program counter low and the program counter high. That means program counter high and program counter low, these two content again 80 and 07, okay. The program counter high content will be 80 and program counter low content will be 07. So again it's starting from the 8007 location and until running. When the halt instruction is executed, the microprocessor will be stop the program. So this is the concept of single subroutine. So in the next session we'll discuss about that what is the subroutine within a subroutine. That is our next concept, is subroutine within within a subroutine. So that is known as nested subroutine. This is known as nested subroutine concept. Okay, this is very important. What is the concept of nested subroutine? Is very easy. Basically, suppose our main program starting from 800, and here from 8004 we execute call instruction, and first subroutine location is 900. Here this is a 900, and here execution of some code, and suppose this from 9005 we here again call B000 X location, and from this B00 location here again writing some line of codes, and here return, say for B009 here we execute return, and here from 900C we execute return. So from these 800A here we execute all instructions. So student, please, this is very, please listen carefully and also see this carefully. So first of all, when the microprocessor execute the code, so program content will be 8000. Okay, so first of all, this is the program content. So after using some increment value of program counter 800, 1, 2, 3, 4, when this call instruction is executed, microprocessor understand that it's jumped to the first subroutine. So this is the subroutine 1. Okay, it's very easy. So when the subroutine address is 900, the program counter content is 9000. Okay, so that's why this program counter starting from starting from 900, and after some line of code it's again execute calls B00. So this is our subroutine 2. So it again jumps to the B00. Now the program counter content will be B000. Okay, so now here what is the return address? 8005, 8006. These three are used for call. So this the return address is 8007. And what are the situation here? The return address is 90567. That means 9008 is the return address from here to here and from here to here. Okay, because I again repeat, when this call instruction is executed, then from this 900 location, starting from this 90 location, the subroutine is starting, and after getting the next call instruction, the next location is B00. So from the latest update of program counter is B00. So it executes this subroutine, and when it gets the return instruction, then at first this subroutine goes to the second subroutine. Let us consider this is the first subroutine, this is the second subroutine. So this second subroutine is first coming to the 9008 hex location to execute the first subroutine. So now after getting this some line or execution of this code, it again return. And what is the return address? The return address is 8007. So these return address 9008, these return address 8007, these all are stored in the stack. Okay, when this return instruction is executed, then this data 9008 and 8007 are individually because for this return, these 9008 are retrieved from the stack, which is stored in the stack when we execute the call instruction. And when this return instruction is executed, then this 8007 hexadecimal data will be comes out from the stack or retrieved from the stack and placed in the address bus or program counter to continue the flow of the program. Okay, so again repeat. So last one is the final one. So what is our program sequence? Our program sequence is a call instruction. So from this call we jump here. So 900, after execute some line of code, we again jump here, call B00, and after execute some program, this return from this return value. So first program counter jumps to 9008, and after execute some line of code, it again take the return value, and after this return value it again jumps to the 8007. That means in the main program. So this is subroutine 1, this is subroutine 2, and this is main program. So this is the subroutine within this subroutine, not in this main program, because this subroutine is within this main program and this subroutine is within this subroutine. So that's why this subroutine is known as nested subroutine. Okay, that's why it is known as nested. It is called nested. Sorry, here is a problem to read. nested, extremely sorry, nested subroutine. Okay, so this is the concept of stack and subroutine.